Hello everyone. In this video, we are going to discuss about subsets, then subsets of real numbers and universal set of class 11 maths from the chapter sets. First of all, let us talk about a subset. See, let us consider a set A. The set A is said to be a subset of another set B if every element of A is also an element of B. Okay, two sets A and B we are considering here, and set A is said to be a subset of another set B if every element of set A is also an element of set B. That is, for example, consider a set X which is a set of all students in your school. Now consider another set Y which is a set of all students in your class. So we know that the set of all students in your class, that is already, all these are actually the elements of the set X, which is a set of all students in your school. Because all students in your class, it is already included in the student list in your school. So every element of set Y is also an element of set X. So we can say that Y is a subset of X. See, we usually use this simple. Okay, this actually stands for is a subset of or is contained in. So here we write Y is a subset of or Y is contained in set X. So set Y. Now let us consider a set A which is a set of all divisors of 56. So all divisors of 56, that is actually the set A. So which are the elements contained in set A? See, all divisors of 56. So 2 is an element in the set A. 4 is an element in the set A. Then 7, 8, 14, 28. All these are actually divisors of 56, or even 56 is a divisor of 56. Okay, so set A has these elements in it. Now we have another set B, which is a set of all prime divisors of 56. So these are the divisors of 56. Now which are the prime divisors of 56? That is, we just want to consider the prime numbers from this. So you see, 2 is a prime number, 7 is a prime number. Okay, so here you can see that the elements in set B, they are already the elements of set A. So elements of set B, it is contained in set A. So we can say that set B is a subset of set A. That is, we can write set B is a subset of set A. And you see, A is a subset of B if an element A, small letter A, it is actually an element of the set A. So A is a subset of B if A belongs to A. Okay, which implies that A belongs to B. That is, A is also an element of B. That is, A is a subset of B if small letter A is an element of set A, implies that A is also an element of B. Let us consider two sets. One is set A, which has these elements in it, 1, 2, 3, 4, 5. Another set is set B, which has these elements in it, 8, 1, 6, 2, 7, 3, 10, 4, 12, 5. Okay, so here you can see that the elements in A, 1, this is here in set B. The element 2 is also here in set B. The element 3, which is also in set B. The element 4 of set A, which is also there in set B. The element 5 of set A, which is also there in set B. Okay, so here we can say that set A is a subset of set B, because you see, every element of set A is also an element of set B. Every element of set A is already contained in set B. So we can say that A is a subset of B. Now, in general, if you see, that is, you see, if set A is not a subset of B, then we write like this: A is not a subset of B. Okay, if A is a subset of B, we write A is a subset of B. If A is not a subset of B, we write like this. A is not a subset of B. Okay, consider two sets, set A and set B here. That is, set A has these elements in it, A, E, I, O, U. Set B is actually A, B, C, D. These are the elements in it. So here you can see that A, which is an element in set A, which is also there in set B. E, which is an element in set A, that is not there in set B. I, which is an element in set A, which is not there in set B. O is an element in set A, but not in set B. U is an element of set A, but not in set B. So you see, not every element of set A is also an element of set B. Right, a few elements would be there, but not every element of set A is also an element of set B. So here, A is not a subset of B. A will be a subset of B if only every element of A is also there in set B. But here, that is not the case. So here, A is not the subset of B. Similarly, if you consider the set B, okay, A is there in set A, B is not there in set A, C is not there in set A, D not there in set A. So, a few elements would be there present in or contained in both the sets, but not every element of set B is present in set A. So, here B is not a subset of A. For capital letter A to be a subset of another set B, all that is needed is that every element of set A is in set B. It is possible that every element of B may or may not be in A. Okay, so let us consider two sets here. That is, set A has these elements A, B, C, D in it. Set B has these elements, that is A, B, C, D, E, F in it. So here you can see that A is in B, B is in B, C is in B, D is also in B. So every element of set A is contained in set B. So we can say that A is a subset of B. But here you see, every element of set B is not contained in set A. See, a few elements are there common in both the sets, but E and F, which are elements in set B, not in set A. So every element of set B is not contained in set A. So here B is not a subset of A. Okay, this actually means that is A is a subset of B, but B is not a subset of A. So what does that mean? A is actually not equal to B. The set A and B are not equal sets. Now let us consider these two sets, set A and set B. Here you see, every element of set A is also an element of set B, because A is here, B is here, C is common in both the sets, D is also common in both the sets. Okay, the order of listing the elements, that is not important or relevant here, so no problem of the order. Okay, so you see, every element of set A is also an element of set B. So here we can say that A is a subset of B. Okay, similarly, every element of set B, it is also an element of set A. So here also we can say that B is a subset of A. If A is a subset of B and B is a subset of A, then we can say that these two are equal sets. That is, set A will be equal to set B. Okay, that is, A is a subset of B and B is a subset of A if and only if A is equal to B. Okay. Now you see, every set A is a subset of itself. Okay, that is, A is a subset of A, B is a subset of B, C is a subset of C, R is a subset of R, Z is a subset of Z. That is, every set A is a subset of itself. Then, empty set, phi is an empty set or null set. Empty set has no elements. So we say that empty set is a subset of every set. Now, if we consider the set R, which is a set of real numbers. Real numbers, they actually contain both the rational and irrational numbers. Then set Q, which is a set of rational numbers. Okay, so you see real numbers has both the rational and irrational numbers, and Q, it is a set of rational numbers only. So you see Q is a subset of R, no? Because rational numbers are already there in the set of real numbers. So we can say that Q is a subset of R. Okay, now let us consider another set, which is set A. Okay, set A has these elements 1, 3, 5, and set B, that is a set of all x such that x is an odd natural number less than 6. So which are the elements in set B? X is the element of set B, but x is an odd number less than 6. So odd number less than 6 means what? 1, 3, 5 are the odd numbers less than 6 now. Okay, so 1, 3, 5. So you see set A has 1, 3, 5 in it. Set B also has 1, 3, 5 in it. So here we can say that A is a subset of B and B is a subset of A. Okay, if A is a subset of B and B is a subset of A, then A will be equal to B, because you see both the sets are the same. No, set B has the same elements, set A has the same elements. So they are equal sets. Now let A and B are two sets. If A is a subset of B and A is not equal to B, then A is called a proper subset of B and B is called a superset of A. That is, if this condition is satisfied, that is, we are considering two sets A and B such that A is a subset of B. Okay, that is, all the elements in A, they are also there in B. But A and B are not equal sets. That is, the elements are not the same in both the sets. Okay, in such a case, A is called a proper subset of B and B is called a superset of A. So let us consider this example. We have set A which has these elements 1, 2, 3 in it. We have another set B which has these elements 1, 2, 3, 4 in it. So here you see the elements in set A. Every element in set A is also an element in set B. So we can say that A is a subset of B. Okay, but you see the elements in both the sets are not equal, not the same. So A is actually not equal to B. So this condition is satisfied. So here we can say that set A, it is actually the proper subset of B. Set A is the proper subset of set B. Okay, now you see, if you consider a set A, if it has only one element in it, then we call it as a singleton set. That is, if you consider a set A which has only one element, small letter a in it, then the set A is a singleton set. Now, let us talk about the subsets of set of real numbers. Set of real numbers means capital letter R. Okay, now subsets of set of real numbers. You see, a real number is any positive or negative number. This actually includes the natural numbers, okay, the whole numbers, the integers, okay, the rational numbers, then irrational numbers, etc. Alright, so you see all these are the subsets of the real number R. So you see the set of natural numbers, that is a subset of real number, because real number has any positive or negative number, that is actually there in the set of real numbers. Fraction is there, decimal points, decimal numbers are there, point numbers are there. So here you see, if you consider the set of natural numbers 1, 2, 3, 4, 5, etc., that is already there in all the elements will be already there in set R. So you see the natural number is a subset of real number. If you consider the all numbers 0, 1, 2, 3, etc., they are already there in the real number set. So this is also a subset of real number. If you consider the integers, that is minus 3, minus 2, minus 1, 0, you can extend the values to this side, minus 4, minus 5, minus 6, etc. Then 0, 1, 2, 3, 4, 5, 6, etc. So all these are already there in the set of real numbers. So the integers, that is a set of integers, z is already a subset of the real number r. Now if you consider a rational number means, you see, you can write it in this p by q form, and this p and q, they are actually an integer, and q is not equal to 0. Okay, that is q is a set of, it is a set of all numbers x such that x equals p by q, where p and q are integers and q is not equal to 0. So this is already a set of, or this is also a subset of real number. Now if you consider the set of rational numbers, t stands for, irrational numbers. So t is for irrational numbers. So if you consider the set of irrational numbers, you see it is a set of all x such that x belongs to r. Okay, that is all real numbers. But x does not belongs to, x does not belong to q. That means x is actually a real number, but they are not rational. So all real numbers that are not rational are there in the set of irrational numbers. For example, root 2, pi, root 5, etc. They are actually irrational numbers. So all these are actually the subsets of real number set R. So you see some relations among these subsets can be written like this. The set of natural numbers, that is a subset of integers, and that is a subset of, the rational number. Okay, this is natural number, integer, rational number. And if you consider the set of rational numbers, okay, that is a subset of real numbers. And if you consider the set of, irrational numbers, that is a subset of real numbers. And if you consider the set of natural numbers, that is actually not a subset of irrational numbers. Now let us talk about the universal set, which is represented with this capital letter U. You see, universal set is a basic set. That is, for example, if you learn about, or for human population studies, the universal set consists of all the people in the world. That is, the basic set which is relevant to this contest is set of all people in the world. Okay, now while we are studying about integers, that is, we can have numbers -3, -2, -1, 0, 1, 2, 3, etc. to the right side, etc. to the left side as well, because here we can have -4, -5, -6, etc. So while we are studying about integers, the basic set can be the rational numbers, that is a set of rational numbers Q, because all the integers are there in Q. So Q is the universal set for this contest. Or you can take the set of real numbers as well as a universal set, because all the integers are present in real number as well. Okay, in this set as well. Now, see, the set of integers Z, it is actually a subset of the set of real numbers R. So here R is the basic set, okay, or the universal set. So universal set is the basic set actually. Alright. So in this video, we have learned about subsets and universal set. I hope it is clear to you. Thank you.